Microservices. Microservices is like one of the hottest topic these days in software architecture field. Everybody wants to jump into microservices, and I mean they're interesting. They have their own pros and they have their own cons, of course. So we would touch upon it. But before starting the presentation, I just want to give my thoughts on microservices. And what happens with people is that, every time, especially in technology field, every time there's a new buzzword, everybody wants to hop in. Yay, it's going to solve all our problems. Microservices, they are great. But like anything in life, everything has its own pros and cons. And often what people make mistake of is they don't really understand the technology well, in the sense that they don't understand all the drawbacks, right? They just would hop on, and turns out that sometimes you get into a disappointing situation because you thought it's going to solve all your problems, but uh, it isn't true. I mean, it comes with its own drawbacks. Microservices increases complexity in a lot of different ways. I'm actually going to touch upon several of this. Although I'm talking about microservices, I also want to talk about drawbacks and why you probably should not use microservices, so as to give you both sides of the picture. It's almost about 7. I'll just wait for, I would just wait a minute or two uh, before starting. We have about 47 attendees right now. I'm actually in the west coast of US, so it's 10 o'clock in the morning for me right now. Um, I think Italian time is 7 in the evening. And I'm not sure, I'm assuming that not all of the attendees are from Europe or from Italy. So we have a pretty diverse range here. So thank you all for joining. We'll just wait for 1 or 2 more minutes and then we are on our way. Okay, so we have 50 people, 52 people, more and more people are coming. 53 now. Excellent. I'll just wait for 1 more minute and then we can start. Okay, so 52 attendees, so 54 attendees so far, including the organizers. Okay, all right. So let's get started. Good morning or good evening, everyone. My name is Nikhil Barthwal. I'm a tech lead at Google, and I'm going to talk about event-driven microservices. Right? I want to talk about how to implement them, what are the challenges, distributed data, so on. Touch upon a lot of aspects related to microservices. This is more like an architecture kind of discussion. Um, I'm not going to go into specifics of implementation. There are different ways of implementation, a whole bunch of frameworks and tools and technologies and so on. That's kind of, we're going to talk more about the architecture aspect of it and more on the design, and try to understand the pros and cons of the design decisions that we would be making. So let's get started. So I'm going to start by the agenda. We're going to start with what are the motivations we have for moving to microservices in the first place. And then I'm going to talk about understanding the distributed data in microservices, which is a big problem, understanding domain-driven design, what's the use of, how do we use it in microservices, the problems associated with distributed data. I'm going to then start into event-driven microservices and what problems they solve, and then various communication patterns, how to use them, what are the pros and cons. Then we're going to touch upon some event sourcing, CQRS or command query responsibility segregation. That's a pattern very commonly associated with event sourcing. It's a scary looking name, but in reality it's not that complicated. And then finally I'm going to talk about sagas, and we'll talk about some of the examples and end the presentation with resources for further reading. So we're going to talk about, like, I'm going to have like about 35 minutes worth of content, and then I'm going to leave the remaining time for Q&A. Okay, so let's get started. I'm going to start with the monolithic, right? That's the old school approach. We have a very simple system. We have a web service connected to a database. You have different clients, your desktop, mobile, tablets, ever-growing systems that can connect. Everything is so simple. Life is so good. Easy to deploy. We just have one service. We can test it thoroughly. Great. Why? What's the problem? The problem is it doesn't scale. And the reason why it doesn't scale is because there are several problems with monolithic once we get into the scaling part of it. It's large code base. Large code base would mean slower development time. We need more time to test and deploy. Imagine something like Google or Microsoft deploying their service, right? It's going to be a big service. Every time you have to deploy, it takes like hours and hours, probably days to test. It's just not possible. And then you have too much of team interdependency. So you have these teams, and because the release is going to be coordinated and you have so many teams that are actually going to coordinate, it kind of slows down everything. So the problem with monolithic is it does not scale very well. It works very well for simple problems, but as your code base grows, it doesn't scale very well. You need something different. So now we enter into the area of microservices, the brave new world. What are microservices? Well, smaller code base, easy to understand, basically divide its assembly of services, right? You divide your monolithic functionality into a set of different services. Smaller code base would make it very easy to understand and change. Teams are now autonomous. I'm not dependent on other release coordination with other teams, faster testing and deployment because it's a smaller code base. So we have solved a lot of problems. It's essentially an assembly of loosely coupled services. I should have a word of caution here that while microservices do scale very well and microservices do solve a lot of problems, one drawback of microservices besides the distributed data is that you need to have a lot of automation in practice, right? DevOps and all those things, because typically organizations have many hundreds and sometimes thousands of services. The startup that I used to work for had 1,000 microservices. I think Uber counted 7 or 8,000 services, microservices, the last I talked to them. And so when you have so many services, right, it's not possible for you to do things manually. So there's a lot of automation that goes into the practice. Okay, can't see I'm just getting a message. I can't see the screen now. Hold on. Let's actually. I'm just gonna pause. I don't know why the screen is not visible. Sharing. Okay, show my screen. Okay. Okay, I'll have to start from the beginning, so I'll just gonna go very fast. Okay, so we are gonna start with. Sorry about that. I didn't really. Okay, so let's start here. We go over the agenda. We move from monolithic to microservices, understanding distributed data using domain-driven design, partitioning of data, problems with distributed data, event-driven microservices, communication patterns, event sourcing, command query responsibility segregations, sagas, and finally resources for further learning. So start with monolithic service, simple service, easy to deploy, test, great. Doesn't scale very well. We know the problem. Large code base, which means slower development. More time to test and deploy, just not practical in a large organization. Too much time, too much of team interdependency, because you have one service, all the teams have to now coordinate with each other, which is really not very practical in a large organization. So we solve these problems using microservices, right? Brave New World, it's basically an assembly of smaller services. So what you have is you have smaller code base to understand and change, autonomous teams, and now you have faster testing and deployment. Great. And now you have assembly of loosely coupled services. So this is how microservices would look like. Just as a word of caution, typically organizations have thousands of services operating. Uber, for example, had 7,000 or more Jet had 1,000. So when you have so many services, microservices, you need a lot of automation. Monolithic, you actually don't need that much of automation because you only have one. So that's one of the drawbacks of microservices. So if you want to adopt microservices, you have to invest very heavily in tools, just as a word of caution. So we're going to look at this topic more. So what microservices really bring to the table. What How microservices solve the problem is they have loose coupling because you know you have distributed data. So typically each service would have one database. You have different services, you have a database connected, and then what that means is that loosely coupled services means reducing team interdependencies. Now this mini database is exposed to me as an API, right, that I can use. I don't really have to worry about the schema of database as long as the contract between the service doesn't change, which happens, but it's not so frequent. And if it happens, you have to coordinate with the team, of course. But as long as the contract does not change, what happens inside the service is really not my concern. So I can just consume this as an API level. And what that does is it reduces team interdependence. As long as I don't change the public API, I can do anything with the private stuff. The other team doesn't really have to depend on me. So what that gives you is faster innovations. Now teams have independent releasability. They can release the service. They don't have to be dependent on each other, and faster innovation, right? I'm going to take a side step here. And really speaking, when people think about microservices, they think about something brand new and flashy. In reality, microservices aren't really a brand new thing. In fact, we already saw what is an object-oriented programming, right? What is an object-oriented programming? You divide your code base into small chunks of objects, and these objects have private method and public method. And what happens is that you have a public interface, and as long as it doesn't change, whatever you do in private is kind of hidden from the outside world. In some ways, microservices is nothing but taking that idea of object-oriented programming and applying to the web service. So you have this database, which is private, and then you have this public API. And the state of the system, which in object-oriented programming is basically the private members, is kind of hidden. And you manipulate the public methods to query the data. And here, what you're doing is you have this API that you basically query, and the state of the database, you can't access the database directly. So microservices is basically an application of object-oriented programming applied to the world of distributed systems and web services. So let's now take a side step and let's talk about domain-driven design, and then I'm going to tie back and see why domain-driven design is important. So domain-driven design, it's a big topic, and I'm going to just scratch the surface of it. I'll end up with some resources that you could read later on. But domain-driven design, basically, this is the textbook definition. It's an approach for software development for complex needs by connecting the implementation of evolving model. But at the heart of it, what it is you have a model of your system, right? A real life physical model, and your software reflects that model. So you basically have model that consists of entities, value objects, bounded context, aggregates. We'll just look at aggregates in depth because that's the one that is particularly of importance to microservices. So your system can be thought of, this is a simplified model. It's a 4-layered system. Your system thoughts of a user interface followed by basically a transaction layer and application layer. And what DDD preaches is most of your code is actually going to reside in the domain layer. So domain layer is basically what models your physical system. For example, if you're writing a software for an automobile, you have various components of automobiles, right? So they basically form your own, what is called as particular domain. Like you have, I don't know, I'm not much into cars, but I'm assuming there'll be engine, there'll be exhaust. Your software gets mapped to physical entities. So that's the domain, and that's where your bulk of your code would reside. And finally, you have the persistence layer or the infrastructure layer. Now, this is a simple model. In real life, you actually have models that are more complicated. Netflix came up with an hexagonal model because they They talk about some various stubs that they create for testing. Now, I'm not going to go into the details of domain-driven design and various models, but what I'm going to talk about is aggregates, because this is the stuff that is important for in the world of microservices. So what aggregates are is it's a cluster of domain objects that you can treat as a single unit. Let me actually give an example. Let's say you're designing an e-commerce system, something like Amazon, Jet, Walmart, whatever, right? You have various entities. You have these objects like, you have customer, you have order, you have warehouse, you have goods, and then they can be clustered together. For example, user places an order. That order consists of certain items. I bought some laundry detergent, I bought some food items, my grocery cart basically. This cart is treated as a single unit, right? And the components are root, basically my order ID, that's the root, and I treat this cart as a single object. And any reference to any object inside this cart would go via the cart ID, or basically something that identifies the cart. So that's an aggregate, right? And a domain model can be then thought of a collection of aggregates. Now, why are aggregates important in microservices? Why are we even talking about domain-driven design? Turns out, we talked about microservices, we talked about partitioning of data, but how do we do that? What methodology do we use? What aggregates bring to the picture is aggregates basically gives you boundaries. So for example, I can break down my problem into small chunks, right? I can break down into collection of aggregates because my domain model is a collection of aggregates, and I have these natural boundaries where I can divide the service. Now, I should also mention this, that this is just an example. I mean, you don't really have to do it this way because there is no unique way of identifying aggregates. For example, I can just say order service, and I can just say customer service, and I can combine the products and customer into one service. I can also combine the product service into order service. So what aggregates give you is aggregates give you the boundary where you can partition, but there is no one unique way in which you can divide your system into parts, right? You basically have to, it's more of an art than a science on how you actually partition a system. But nevertheless, what domain driven design is basically bringing to the table is bringing those boundaries where you can actually divide the system. Okay, to talk about distributed data and domain driven design, what are the problems associated with domain driven designs? Now, we know that we have a consistency issues. For example, a customer places an order, right? There has to be a set of actions that have to be associated with it. I place an order, certain money has to be, removed from my account to pay for the goods, the inventory has to be updated. What if I place an order and I check it out and the inventory is not updated? It still shows that the items are still in the warehouse, right? There's an inconsistency. Now, when you have distribution of data, you need some mechanism to keep that data consistent with each other. So that's problem number one you have with distributed data, how to keep the data consistent. The second problem is, now that I have distributed data, right, how do I query them? It's not that easy because what happens is each service has its own database, and database is private to that service. I don't have access to that. So I can't access to the table directly. I have to basically now talk to the service. But the point is, my data is scattered around many services. So it's not one query that I can run. I basically would have to run several queries to different services, aggregate the data. So distributed data in a microservice architecture is a problem, is a huge problem. And there are ways how you mitigate this problem, which I'm going to go into details about it. So let's start with the problem itself. What we have, well, in good old days, we have an asset transaction, but we can't use them because imagine this query. So I basically, what I want to do is I want to create an order. So I want to create an address from the customer, and I want to create the price of the product where customer ID something. But the problem is, this is a separate database, and now this also is another database. So I can't run this query as it is. because this query spans two different services. So how do I run this query, right? I can't use an ACID transaction. I also cannot use two-phase commits. They do guarantee consistency, so that's not a problem with them, but the two-phase commits have several problems. Coordinator becomes a point of failure. It's a very chatty system. Locks and throughputs will decrease the throughput, and hence availability gets impacted. Now, the very reason why I moved to microservice was faster innovation. Now, if I have web services and I'm decreasing throughput, and basically it's a loss of revenue for me. And coordinator becomes a single point of failure. What do I do? So two-phase commits, while in theory can guarantee consistency in a microservice architecture, it it there are problems with it. So I can't use two-phase commits. Now I actually have to use something like an eventual consistency. Why? I have this CAP theorem, right? Consistency, availability, partition. There are three things, and I know that I can't have these things together. Now, by definition, distributed system has partition. So partition has to be there. Availability is also very important because for me, availability means revenue. If my system goes down, I can't take customer orders, and that means loss of revenue. Imagine for every second of if Amazon is down, they're probably going to lose thousands, if not millions of dollars worth of orders. So they can't sacrifice the availability. Consistency is something that I can punt a little bit. So what I'm going to do is I don't want a very strict consistency. I want something like an eventual consistency. And when I say eventual doesn't mean that data would synchronize in like hours. Eventual often means few milliseconds, microseconds, or at best few seconds, right? So for example, I place an order. The the warehouse doesn't need to be updated immediately that certain items have been shipped, right? It can be updated after maybe 1 or 2 seconds. It's not going to make that much of difference. So in microservice world, where we move to is we sacrifice consistency for what we have as eventual consistency. And this is where event-driven microservices architecture come into picture. A lot of people, they confuse microservices with event-driven microservices, and they think it's one of the same thing. It's not. Microservice is a pattern where I have a division of labor. I take this one service and I split it into different parts. But there are several different ways of implementing microservices. Event-driven microservice is one particular approach, and that particular approach lets me have a service which has high availability and partition tolerance where I sacrifice eventual consistency. Now, there are cases where consistency has to be strict, and I can basically punt a little bit on availability. And in those cases, event-driven microservice architecture is not the best one to be used. But in real life, in most cases, consistency can be replaced as event consistency, and that is the reason why event-driven microservices are so popular, to a point that event-driven microservices has basically become synonymous with microservices, even if they are not the same. So let's actually look at it. Let's look at some layman examples of what event-driven microservice is. Like everything in technology, what they have is they have these fancy names for what is often a single simple concept, right? And we have been familiar with these concepts for ages, we just don't realize it. Microservices, as I mentioned, is simply nothing but object-oriented programming applied to web services, and we have been using object-oriented programming for, like, I don't know, 4 or 5 decades. So it's not something very new. Event-driven microservices, we use it all the time in layman situations. So let's actually look at some examples of what event-driven architecture is. Simple. Event occurs in a system whenever a change happens, and then all the listeners gets notified, and some may take an action and some not. And it's a very highly distributed systems in the sense that the message gets broadcasted. There are these individual listeners. The listeners are not aware of, like, the sender is not really aware of who the listeners are and what action do they take. He just broadcasts the message, and it's often used for asynchronous flow of information. A very common event-driven architecture is airports, right? Every time You go to an airport, an announcement is made, flight ABC is going to leave in 15 minutes. The broadcaster makes a broadcast, that's an event that gets broadcasted. And then you have these passengers who are basically listeners. And some of these passengers would take any action, particularly the ones that are going to board that flight, and others who are not going to board the flight would not take any action. Very simple, highly distributed, very loosely coupled. The listeners are not aware of each other, the sender is not aware of the receiver. That's a perfect example of event driven architecture. You have the same thing in a way applied to microservices in the sense the event happened and event is generated and it's passed in the event bus. We'll look at the architecture in more details on how that happens. And there are other services that basically listens to that event, and they can, if they need to, take an action. Another so let's look at the communication models for event driven architecture, right? One way is a direct communication model. You have these different services, they talk to each other. Simple way of doing it. They obviously have some advantage. It's a very easy implementation. It pretty much works very well with serverless also, which is the next hottest thing people say. It comes with its own drawbacks. Increased coupling. I need to know whom to send the message, and it sort of defeats the purpose of microservices, that the very reason why I moved to microservices was loose coupling. So teams have faster innovation by individual different releasability. Now, if I increase the coupling, I'm basically increasing, slowing down the speed of innovation, which is usually not a good thing. Also, it's difficult to scale. Now, if in this case it's a simple scenario, but what if the scenario becomes really complicated? I have to track about all these services, new service. If I have to introduce a new service, it's basically a graph. Then I'll update that particular service and it'll talk to n number of other services. Then I also have to update those n services to talk to this service. Simple scenarios it works, in complicated scenarios it doesn't. The other way is via message broker, Kafka being the most common message broker. Then if you're on the cloud, Amazon, Azure, they have their own service buses. In fact, they have many implementations of service buses. So you have these message broker in between, and the services, they just publish the message to this broker, right? Google has PubSub. I just publish it. I have these topics. I can subscribe the feed, and I just listen if I need to. It's very scalable, right? It also decreases the coupling because now I just have to communicate with the message bus. I don't really care what's happening, and there's a little bit of an error control here that I can build in, but there are drawbacks. Broker is a highly available component, right? If the broker fails, you're basically screwed. Also, the visibility is less in the sense that I send the message, it goes to an ether. I don't know what action was taken, if at all. So you lose the visibility of your system, and that's the reason why there are a lot of distributed tracing frameworks like Zipkin exist or Jaeger exists, because to mitigate this problem, that when you have a message broker, I don't know what's happening. Communication is happening via asynchronous messages. So yeah. So let's see how these communication patterns are actually used in practice. Now, typically, I can divide my services into three tiers, right? I have a direct customer facing, I have customer impacting indirectly, or sometimes I have some services that don't impact the customer. For example, let's say I'm running Amazon.com, or again an e-commerce site. If my order placing service is down, a customer cannot place an order. That's a direct impact. If my fulfillment service is down for 15 minutes, the customer order gets delayed by 15 minutes. So there is an impact, but it's not going to be a big impact. I mean, if I order something, if instead of coming tomorrow, it comes like tomorrow evening, unless it's an expedited order, it would not make a lot of difference to me. And then there are these tier 3 services like monitoring, telemetry. The customer doesn't care about how you monitor your system. In practice, how we tend to do is we tend to use request response system, or the standard way of communicating, on your tier 1, and we tend to use event driven architecture on the tier 3. The reason is that you need a very high error control. If my order service is down, I don't want the customer to be waiting, right? I want to notify the customer something went down. If I can't place an order, something like that. So there I need a synchronous system. I take an action, I need what's the outcome. I can't just wait and I don't know what's happening. I can't have a loss of visibility in customer facing. So there are drawbacks of request response, but for customer facing, it makes sense to use them. Most of the services generally will fall into tier 2 and tier 3, and there I would use my event driven architecture. So where I'm getting at with this is, often in real life, it's not like you have one particular way that would solve all your problems or one particular architecture. Real life is a little more complicated. You have to, different parts of the problem, you need to solve it in a different way. It's the same thing as everybody hops onto microservice, everybody hops onto this technology, that technology. Every technology has its own limitation. So you basically have to decide what is the best for this problem. And for some problems, request response, for all the drawbacks they had, to make sense. So real life usually will will consist of a mix of regular microservices and event-driven microservices. It's not going to be either one of them. um, since I prepared this slide, now you have serverless and all these autonomous systems, and so I would say going forward, your most modern systems will be a combination of simple web services running in a container and serverless. In fact, you could implement an event-driven architecture using serverless. Of course, there are pros and cons of it, and that's a whole different topic actually that I don't want to go into because I want to limit the scope of it. But you can do that. So anyhow, so continuing, let's now introduce event sourcing. We have been talking about events. We kind of understand what event is, but we now want to formally introduce event sourcing. And event sourcing is one of the things that you hear a lot, something new, but in reality, we have been using event sources all the time. So we model the state, change the sequence of events, we store the events that trigger, and then it lets us enable back to a particular time in history. So that's the advantage of event sourcing. We have used event sourcing in a whole lot of real life situations. For example, bank account, right? I Every time you buy and sell, you have a bank ledger that would say, okay, fine, I started my account zero, I deposited $1,000 or 1,000 euros, I bought something, I withdrew 20. It's a set of entries. So each entry is basically an event, and your state of the system is built by playing down these events. So for example, I can add and subtract all the debits, transactions, and credits that I do on my account, and I get my final balance. Event sourcing, what it enables you to do is enables you to roll back in a particular time, and you can see what's happening in that particular time. You can also play around things in the sense that you can remove one event and you can combine these events in a different way. For example, a credit card statement, I call the bank and I say 15 days ago, there was a fraud transaction on my account. So what bank would do is it will roll back 15 days, it would remove that fraud transaction, and then it will play back all the events minus that one event, and you can build another state. So events would let you combine and recombine the state of the situation. That's a big advantage. Of course, there are difficulties in implementation, so that's the drawback, but that's what event sourcing is all about. Another common example is version control. You start with a clean slate and you make a series of commits, right? As you commit, I'm building a software, I'm making every series of delta, and your final state of the system is a sum of all these deltas. Event sourcing, another classic example of event sourcing. So here's another example: Facebook or any kind of social network, right? An event happens, and applications, they process the event, and then what happens is they might create a different view. For example, I post a photograph on my timeline. So my timeline picks it up and it attaches it on the photograph on my timeline at date X. This is what happened. The photos application picks up that same event and it puts a photograph there. My personal section, which has my personal details, gets that event and ignores them. It doesn't have to do anything with the photograph, right? So the same event is read by different application, and depending on the application, it may take an action, or different action, or perhaps no action at all. Event sourcing comes up with its own drawbacks and its own benefits. Well, on the benefit side, we have a very accurate logging. We can do time-based queries. We can process the same events but create different views. We saw that. Of course, there are drawbacks like anything, and drawbacks is it adds a lot of complexity. There is no strict consistency now because you have these events and not everybody is going to read the event at the same time, right? So you have a kind of an eventual consistency, assuming your system is 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 responsive enough. You would eventually have consistency, but you won't have a strict consistency. You also have to build a state every time, so you have longer boot up times. Although in most practices, what people tend to do is they take snapshots over a period of time. So let's say the bank has to build your account and you query your account today. The bank doesn't go all the way to transactions 5 years down the line and then tells you what your account balance is, right? It has some kind of snapshot or some kind of temporal like state saved in between. But anyhow, that's one of the drawbacks of event sourcing. Another pattern associated with event sourcing is CQRS, or command query responsibility segregation. And what it is basically segregating the read and write. And so I can just basically read these events and I can build a different query model that you can view. And when you basically use event sourcing, CQRS pattern is kind of necessity because you don't really have a view of the system, right? Events basically would build it. So you basically read these events and you build a state of the system and then you can query it. So the difference between a command and a query model. CQRS has its own drawbacks. The benefit side is needed for event sourcing. It improves separation of concerns. And of course, you can have different views because now you have these different services reading these events and building a different view. But it adds complexity to the system. There's a code duplication, and of course there's a replication lag, right? We discussed the whole idea of event driven is we are basically trading strict consistency with eventual consistency, so there is always going to be a lag. Let's move towards the final part of the presentation of sagas. Now we have talked about all of the ways that microservices can communicate using events, so on, but how do we actually practically implement them? Turns out sagas was something that was basically introduced around 1987. So this was the original paper coming out of Princeton. The professor who wrote it now is in Stanford, but that was 1987. And it's basically based on that paper. And initially it was just running for a single database because at that time there was no distributed systems, and now it has been adapted for distributed systems because in distributed systems you have a concept of partial failure. What it is because every transaction is supposed to have a rollback transaction. So for example, I have a transaction and I have a rollback transaction, and this logic must be included in service. Obviously, it complicates the implementation, but it helps you deal with how you respond to the events. So now I have a transaction, let's say transaction T1 gives to transaction T2, and then what happened was T2 should have given to T3, but for some reason T2 fails. We talked about partial failure, right? In distributed systems, you have partial failure. So what you would do is this would not happen, and it will turn out to the rollback transaction associated with the initial action. So every transaction here, T1, T2, T3, has a corresponding rollback transaction R1, R2, R3. And if that operation fails, we can go back, roll back. So let's actually see a practical implementation of this. Okay, so here's an example. So we know sagas are long-running compensation. They have long-running transactions. They have compensating actions. Let's look at an example from a banking industry. Okay, so I want to deposit a check. What happens? This action would initiate a saga. The first thing that would happen is, let's say I'm giving a money to you. Do I have enough money in my account? If so, I should move to the next action, and that is withdraw the money unless it's in hold. And once that withdrawal happens, it goes further into the deposit. And let's say if I can't withdraw the money, it will go back to the starting of it. Now, this is a simple scenario, but you actually can get into a complicated scenarios with this also. For example, let's say that I want to give the money to you. So I start a saga, deposit check. I start a saga, take $100 out of my account and give it to you. So $100 is deducted to my account, but around the same time, you closed your account. So what happens? Well, the next action cannot happen, so the rollback transaction would happen, which means the $100 should come back to me. As it turns out, just when it was about to be sent, I closed my account. So now you have both of these accounts that are closed, and there is this $100 that is floating around. Nobody knows what to do. So the point I'm trying to make is, while this is a simple example, in real life, life is not so simple. You actually have to do a lot of analysis on what your transactions is going to be, what are your rollback transactions, how you're going to deal with it, so and so. I would end this presentation by giving you some of the resources. Building Microservices, Sam Newman is a nice guy. I think he's writing, this is the 2015 book. I think he mentioned to me that he was writing a new version of that book. I don't know when it's going to be out, but this is a very classic book. It's mostly about ideas and designing fine-grained systems. It's not so much on the implementation. The classic blue book on domain-driven design, I actually, just touched the surface of it. But as I said, domain-driven design is a big topic. There are conferences dedicated to it. Then obviously Chris Richardson has this book on microservices patterns. It talks a lot about sagas, how to implement them on the different patterns that you use. There are some excellent links. This is a talk by I think it was Evan's talk. He talks about DDD and microservices and how you basically have boundaries by aggregates. This is an overview of Saga pattern. The site Microservices is actually by Chris Richardson, who's the author of the book Microservices Patterns. So he talks about Saga. Distributed Saga. Katie actually came up with the concept of distributed Saga, and Twitter uses it. So there's some distributed Saga. But again, this is a very small topic, microservices, event-driven microservices, and just about everything associated with it, domain-driven design. All this is huge topic. The web is full of a lot of information. And towards the end, thank you very much for listening. And I am up for questions. Yeah, so you can, I don't know, you can unmute yourself and ask me questions, or we have a chat tab. Me questions if you have anything, or if anything is not clear, please let me know, so I'll be happy to repeat it. Okay. Okay, I should probably, I'm not sure if I'm muted. Not muted. Okay. Okay, good. So, okay. Yeah. Questions, if any? Okay. Let's go one by one. Are you sharing your screen? I think that thing got sorted out. I didn't see the presentation. Are you sharing? Okay. Okay. Sorry, guys. I didn't know. Okay. So let's. Will you share your slide decks with attendees later on? Yeah, that's fine. So what I'm going to do is I'm going to email them to the organizers and they can just distribute it. So that's not a problem. I'll be happy to do that. Can you talk near the microphone? Okay. Sorry, I don't know if I was loud enough, but I think they have recorded it, and you have my contact information. So if you have any question, happy to answer. Can you share some tips and techniques to handle messages which arrive in wrong order? I mean, messages that should be consumed in specific order but arrive in a different one. That's a tricky problem because the very nature of distributed systems, you actually can run into such kind of problems. Um, there is no standard way, but you can always have something like you can have like a sequence number associated with every message, right? So sequence number 235. So if I am processing message number 8 and I haven't processed message number 7, then I know something is wrong. But the problem is that distributed systems can have partial failure. So let's say I process message number 6, and then I got message number 8, but message number 7 never shows up. What do I do? So when you get down into implementations, you have to make a certain hard decisions. For example, you have to have something like you know timeout associated with it. There's no standard way of doing it. It's now very much up to the implementation. Sometimes ordering is not that important, but where it is, it's a good idea to basically have something like an order ID or sequence number, or you can basically attach a trail, which is what very a lot of distributed tracing systems they do. They create a stack. But yeah, those are the ways you would implement it. Is there any important pattern apart from Saga? Saga is by far the most important, but there are a lot of other patterns. The site microservices.io actually, um, let me type it here, microservices.io actually talks about pattern. So it's an excellent site. I would encourage you to think about it. Um, Chris Richardson also describes a lot of patterns besides Saga. Another pattern that I think Jet use, I'm forgetting the name of it. I think it was, yeah, I can't recollect the name, but they actually don't use Saga. They actually use something else. I have to look up at the literature. But yeah, there are other patterns besides Saga, yes. Okay, maybe a little bit out of scope, but if you have a front end for your microservice, is a single application going to request and render all the fragments, or is there a better way? For front end, you probably would have a single application, but that application can have several replicas. And also, um, replicas. Also, you got to understand that generally you have to talk about scalability. So try to keep things stateless as much as possible. And if you have states, then it gets a little bit difficult. But there are, again, it's more of a design decisions. There are no standard way of doing it. Uh, you could have multiple applications because you might have different stakeholders, right? For example, you have a customer placing an order, but you have something like a person from the inventory of basically from your supply chain. He may have a different app front end. So you could have potentially different front ends. You could have more replicas of it. As long as they are stateless, that's not a problem. I think it's a very problem specific thing, and I'm not sure if I have a standard answer for you. What about service registry? Well, service registry obviously is important. I did not touch too much about implementation of it, but if you have different frameworks, they would incorporate about service registry. Service registry would come under monitoring and distributed on tracing and all those things. Those are more implementation details, but yeah, you absolutely need them, of course. Is there a better programming language for microservices? For example, Golang versus Java versus Node? In my, and this is strictly my personal opinion, I would use functional programming languages because I think they are awesome for microservices, and a lot of people they tend to use Scala, or even Kotlin is a kind of newcomer. Golang is popular because it's very highly efficient and it has an excellent garbage collector. And somehow people are more familiar with imperative and so on. So Golang fits because it's a simple, clean language. But again, like anything, better or worse very much depends on the problem you're solving. Personally, I would not use Node, and I'm not a big fan of Java because it's very verbose. Golang is okay, but I would probably use Scala or F Sharp for it. But again, this is my personal opinion. All right. What to do when rollback transaction fails? Well, I just talked about a transaction and a rollback transaction, right? But you have like multiple layers. I mean, if a rollback transaction itself is a transaction that can fail, you have a rollback of rollback. Obviously, there's a certain level of depth that you can have. Like I have 3 or 4 levels of transaction. If everything fails, what can I do? The answer is nothing. I mean, to some extent, you have to have that nothing is 100% correct, right? There will be a limit to the system. I can build all the compensating actions for rollback transactions. I can have compensating actions for all those compensating actions also. I can go into the level depth of 2 or 3 to basically mitigate this problem. I can't really uh, solve that problem completely. To some extent, there will be a problem. Yes. I mean, if everything fails, you can't do anything. Very interesting. Thank you. You're very welcome. To control all microservices, I'm not sure what about service registry to control all the microservices. Yeah, so we already talked about it. You definitely need um, service registry. Now, Jose Manuel has just asked me a question. Is there any important pattern? Okay, I've answered that one. Rogerio, yes, I'm here. Usman, what can be done for message broker point of failure case? Truth is, really not much. But then, message broker is a very standard topic, right? So, something very standard. So, if you're on the cloud like AWS or PubSub or Google, then message broker is something that your provider is basically providing you, and it's their job to basically guarantee. But again, it can fail, and yes, you would be in a problem. Now, certain systems I've seen, they use multiple message brokers and again try to mitigate this problem. I don't know if it's a good idea, but message brokers usually have a lot of resiliency built in them, right? So even if they fail, they can come back up easily. Shouldn't be a problem. How to solve when I have fixed number of resources that can be reserved when using eventual consistency? Uh, in very general terms, engineering is all about trade-offs. Okay, so you have fixed number of resources. You can't allocate everything to everything. Well, you have to prioritize. I don't know if there's any better answer I can give you, but you have to prioritize, and then based on ones that are critical, you would basically assign those resources. There's not much you can do besides that. The presentation was very nice. Thank you. Could you share it? You're very welcome. That was Alexander. Yeah, as I mentioned, I'll be sending the presentation to the organizers. They should be able to share it with you. The slides are all available, and they are recording the video, so the video should be available too. There are some frameworks that implement the Saga pattern. Um, I'm not sure. I think Spring might be able to do something, but I'm not too sure. Also, one of the things that you have to understand with Saga pattern is that it's a very application specific. So the frameworks might not do much. For example, what compensating action has to be done for a transaction? That's something that depending on your application, it depends on what your application is, right? So framework cannot really do anything. I mean, framework would provide you a way of indicating, hey, this transaction has failed, but what action would I do? I don't know. I mean, that's something you have to program yourself. Now I have a question of Chris Verdine. What are your responsibilities as a tech lead at Google? So I am working on Knative, which is basically a Kubernetes-based platform for serverless computing. So Kubernetes is basically an open source. Kubernetes is open source. Knative is open source. Google does have a private hosted version of Knative. I don't think it's probably out yet, but yeah, I'm working more on serverless computing, Knative. Like a restaurant with fixed number of tables or an event with fixed number of seats. How to solve the problem? The resources. I'm not sure if I understand your problem very well, but um, I think it's related to allocation of resources, right? So as I said, you have to basically prioritize. This is very application specific. So I don't know if I can really answer that question. This is something very application specific. Okay, couple of thanks. You're welcome. I will answer each one of them separately. Okay, and then why ESB is considered outdated in microservices environment? I don't know if it's considered as outdated. I'm not too familiar with AWS to really answer that question. Um, Sorry, I don't think I know much about EBS to comment on it. Need to go, thank you, never mind. The action frameworks has brought CQRS and Saga's pattern, but most cases seem to be more complexity than solution. Is not the CQRS more hype than a real need? Seems to be close to Java. I don't really think that CQRS as a concept is a hype. But yes, the implementations, the problem with implementation is there's no standard way of doing it, and you could potentially have an implementation that can be quite nasty. I mean, this is more of an implementation thing, but CQRS is needed in event sourcing. There is no other way of doing it. That's for sure. So I have Francisco says trying to have an automatic transaction rollback versus each operation should implement a different. What's the difference? Each operation should implement a different rollback strategy. Well, there has to be a different rollback strategy each transaction has to. There cannot be an automated. For example, in certain cases, yes, if I'm depositing money and if that operation fails, just keep the money, it's automated. But again, you could have all sorts of corner issues where just simply reversing a transaction cannot work. So you definitely need to have a different rollback strategy for each one. Choreography versus orchestration. I think this is going into depth of it. There are pros and cons, and we can go and get into the depth of it, but I don't think there is one particular way in which you can do that and that fits bad. This is more of an application specific things. You have, it's like an engineering, you have to have trade-offs. If rollback transactions fail, could we roll back to a state where the original transaction was made, for example account closing, then apply the failed rollback which would succeed and then reapply? Which would, you could do that, and in this case it would work, but again, not in every cases. It really depends. I don't think I want to generalize and say this is the way to do it. It works everywhere. It might work in certain cases, but not always. What are my responsibilities as a tech lead? I answered the question. uh, Thank you. So I'll probably send a note to each one of the individual questions, but I just want to quickly talk about them because I don't want to wait people waiting while I'm typing. But thank you. Okay, so now, don't you think that race for scalability causes over abstraction, hence complexity, making microservices worthless from beginning? Nicola asked me that question. I I think you're making a very general assumption, and I don't think that it's true in every case. Over engineering is a problem, and over abstraction is a problem. And like I said, at a theoretical level, I don't think microservices are worthless. They do bring something to the table, but implementation wise, I mean, you could screw it up. So this is a very implementation specific question. I don't think I have a general answer for this one. That's all the questions I have. What I'm going to now do is I am going to basically share answer these questions individually, um, and that's about it. Uh, okay, I think I'm pretty much over with the time, so I don't think I can take more questions. But you have my contact information, and I would circulate my slides. Um, and if you have any more questions, please feel free to email me, follow me on Twitter. I'm always happy to get questions and answer them. Thank you very much.